Good day and welcome to my uh, training where we make structural engineering design simple and easy. My name is Olodukonyede and I'm your host. I want to say a very big thank you to everyone who has subscribed to this channel and everyone who is interested in my one-on-one training, and also inquiries and payment being made. I really appreciate you. So please let's send the dates that we are free so that it won't clash with other people's dates. So just send it. We'll do take it will be a first come first serve basis. So once again, I want to say thank you to everyone who has paid for the one-on-one training. I really appreciate that. The quick response, I really appreciate that. Also, those who subscribe, I say I appreciate you. And those who are yet to subscribe, please hit that subscribe button. So we've been getting a lot of questions from our subscriber, and the subscriber is asking us how to design a raft foundation. The first step, the second step, and I should just explain the steps on how he can be able to design a raft foundation. That's what we'll be doing today. I'll show you how we are able to design a raft foundation, and also we've done different videos. Please check our previous videos for further explanation. Okay, the first thing you need to do in terms of raft foundation is your soil test. Very important. Like this page I'm opening, it shows us that at 1 meter deep, our soil bearing allowable bearing pressure is 36 kilonewton per meter square. When you go to 2 meter, is now 108. At 3 meter, 144. At 3.25 meter is 153. So they did different tests, as in different pits, to get their different soil capacity, but it's within that range. So the first thing you need to do from your soil test is to see the recommended soil pressure that the geotech engineer gave. And for this, the geotech engineer gave us, for shallow foundation, from the available soil condition described in section 3.1 of this report, and considering the proposed warehouse on the site and the subsoil condition as reviewed in the complete borehole DCPT results and lab analysis of selected subsoil samples, shallow foundation in form of a well-reinforced wide base square stroke circular footing of pad and column placed in 1.7 meter below the existing ground level, or raft footing to a depth of -1.2 meter, tied with ground beam to provide a rigid substructure which will allow a more uniform distribution of bearing pressure that will distribute the load uniformly and minimize the likely negative effect of differential settlement could be adopted for the proposed building, since anticipated cross loading is assumed to be 30 kilonewton per meter square. So what we'll be doing here is, from all this explanation, what the soil test is telling us is that that area within 1.2 meter of the soil will assume this soil capacity. So it suggests the depth of the beam. We also had a subscriber asking, how do you do your foundation beam? So how do you determine the depth of your foundation beam? This is a suggestion that will be given to you by the geotech person, the geotech engineer, that okay, the depth at this particular, so you need to do your beam, design your beam that will get to this depth. So the beam will be using will be 1.2. So but if at lower, let's assume at 1 meter the soil capacity is better, we can use that, but for now we'll be using 1.2. so that is how we determine our beam, our ground beam, the depth of our ground beam with this result. So if you look at we are on level 0, story 0. This is what you have, how we arrive at these values is by coming to this place, click, come to column, Asia loads, then you pick the different load combination. But check our previous video, we've done things about this. So but to do your raft, the first thing you need to do is to get that beam, get your beam. We will do 230 by 1 2 from our soil report. Please, I will go to this place, check our previous video. We've done a lot of things before getting to the foundation. So we finished the modeling, design and everything. So you just need to check our previous video to understand how to get to this part. There's a lot that has been done before getting to this part. So check our previous video and you'll see how we're able to model our structure. So we are trying to create the beams, and there is something about this beam and slab reinforcement. It is much more cheaper than just the only slab. When you use only slab to do your raft, it is much more costlier, but this is far cheaper compared to when you use only slab. So I would advise that you should do beam and slab raft, is far better and cheaper. So next thing we do, we bring our slab. Let's start with 150. Every other thing still remains. Please check our previous video for the explanation of all this. So there's something I would like us to know. Our beam is 1 to 2, and if we add our slab, it automatically takes it to the bottom. I'll show you. If you do this, okay, if you do this, okay, if you do this, this is what you get. if you do this, your slab starts at 0. It starts at 0, which is not what we want to do. It's not what we want to do. We want it to be at the top. So what we do is we'll come here, right click, go to property, come to load. This relative level is at 0, but we don't want it to start at 0. What we want is for it to start to be at the top. So we have 120 minus 150. This 150 is the thickness of the slab, so we subtract it, we have 105. So put 105 here, 1050, say update, and automatically it brings it to the top. This is what we want. This is how we want our slab to be. So what we do, we just click, say property, and we start putting in there. And this is it. This is how our foundation is. And we close. What we can do is you right click here to add edit beam load, edit wall beam load. Same principle. Please check our previous videos. We've done all this. Just check the videos and you'll see. All this we've done prior to this. Check our videos. We've done how to edit wall load. I'm not explaining much because we've done it. Check our previous video and you see everything there. You'll see everything there. So we've added wall load. So next is come to analysis, go to FE raft foundation analysis. Please pay attention. Before we do that, we'll come to post analysis. This is our allowable soil capacity. Let's put what we copied or what the soil test report gave to us. We'll put it there. Then we'll come back here. We check all this. Check them. Check. Use the subgrade reaction. Yes. Include soil and column section. Yes. Consider beam torsion. Yes. Do all this. Then after you've done that, you come to this place. This has a range, upper and lower, depending on your soil reports. You check your soil report for it and you place it there. But if not, if you don't know it, just leave the default. Come to this place, say raft foundation mesh analysis. Click it. So you get to this place, generate model, allow it to run. So give it some time, it will run. Give it some time, it will run and bring out, yeah, the result is out. You close and you give it time here, so that it will do all the analysis and show you this X mark without the green good mark or thick mark grain. So immediately it's done, this is it. It brings you to this post analysis. You say analysis post processing, click on that. It will give it time, it takes time, but if your system it has a very fast processor, it will be quicker, but all depends on the system that you are having. Okay, we are here. What you do most time, what I do most time is I click this so that it becomes clearer to me, and come to this area, click your G plus Q. That is what we want. So if you come to here, if you check this area, you see soil pressure. You see soil pressure here. Click on that. Okay, just give it some time. What we've done, so like what I said earlier, you click on this standard contour, it will bring this legend. To bring the legend, click on G plus Q. Your G plus Q, come to soil bearing pressure, click on it. Once you do that, allow it to run for it to bring up. Yeah, so when you've done that, it will bring this. So what you need to check now is already okay, there's something I skip, so we'll close this. There's something I skip. We'll say no, I skipped something before getting to this area. Please let me do that. Very important. That is a big miss. Take your strip, this strip here, click on strip, change it to FE strip. FE strip. Then come to this part. Somebody was asking me of just a slab raft. This is where you determine that, but if you put your cursor at your point here, it will tell you the different slab. This is our beam and slab raft. This is our rib. This is rib. Most time what you do here is for the slab raft without beams, check this or this. These are the two that you can use to draw your strip. So but we are taking this, we draw our strip. Hold Control, draw. When we are here, change this to Y and change this to 1. Okay, we've done that. Very important. Close. Then you can now do this that we've said earlier. Just run it again. Everything that we've done, just repeat it again. So, but if you don't, so if you see, it will run it. Close, allow it time again to run. Once it finish running, it will move to post analysis processes and reports. Okay, so you click on this and we click on, if you check at the last, you see soil pressure, click on it and you click on it, give it some time. Yeah, so if you look carefully, you see the different this arrow shows you the soil pressure of the area. So your area that is under pressure, high pressure, is at the edges. So what we can do most time, but we can either leave it like this and close, or close, we say yes, we say yes. Give it some time to go through. Let's give it some time.